The energy of motion is called kinetic energy. In this lab, you will discover how an object acquires kinetic energy and how it can be changed. This is change in kinetic energy. When I was a teenager, we talked a lot about cars and how much time it took one to go from 0 to 60. Oh, I know what you're thinking. Yes, we did have cars when I was a teenager. I always wondered which was harder, for a car to go from 0 to 30 miles an hour or to go from 30 to 60 miles an hour. Or maybe it's the same difficulty. After I learned more physics, I was able to answer this question and many more. You will too. In this lab, we have a cart instead of a car. It will be pulled by a string attached to a falling weight, unlike a car that is pushed by the friction force from the road. This ensures that the force is constant and measurable, making our analysis easier. The force on the cart will be measured by the force sensor that's attached to the cart. This motion sensor will measure the position and velocity of the cart. And so we have it attached here to the end of the track, pointing directly at the back of the cart. To make sure the track is level, we've adjusted the feet so that if I place the cart at a certain spot, it'll stay put. So I know it's pretty level then. We also want to make sure that the string is level by adjusting the pulley and that it's not rubbing on anything. And so to test that out, we run it over here. And so you make sure it's going over the pulley, not rubbing on anything, and it's pretty level. So we're interested in measuring how the kinetic energy of the cart changes as it is pulled down the track. For that, we need to know the mass of the cart with the force sensor attached. And so it's about 0.36 kilograms. Let's open the data collection software, in this case, SparkView. We've opened it up and we have connected the force sensor and the motion sensor. We've increased the data collection rate to 50 Hertz. That should work well. We need to zero the force sensor when nothing is on it, so the string is off now, to ensure an accurate measurement. So right now the force sensor is reading negative 0.88, and I zero it, sometimes called tearing, and we're all set then. We've set up a display that shows force on the top, position in the middle, and velocity at the bottom, all with time on the x-axis. Have someone ready to catch the cart on the other end of the track so it doesn't go on the floor, and make sure the mass on the string isn't swinging, otherwise it'll affect your force data. Now that everything is ready, we can click Start, collect our data, and then stop after it reaches the end of the track. Before starting the analysis, we should make sure we have measured a good set of data. We can zoom in on the part of the graph that was made while the cart was in motion. So that would be this part. The force graph should be horizontal, but it's okay if there's a little bit of variation, and we see that here with this one, but pretty horizontal. The position graph should show a parabolic curve, concave up, and we have that here. And the velocity graph should be a straight line with a positive slope, just like here. If not, check the aim of your motion sensor. Check to see if the string fell off the pulley and is rubbing on something, or if the mass was swinging, and try again. You want to have good data for this. The force on the cart can be obtained by first selecting the part of the graph where the cart was moving, and then using the tools of the data collection software to find the average or the mean. And so this is the part where it was moving. And so I can select that and then ask the computer to tell me what that is. And so you'll record that. Then we want to find the relationship between the distance the cart has moved and its kinetic energy. Unfortunately, the motion sensor measured the cart's position relative to it. we need to find the initial position of the cart and add to that the different distances in the data table. For example, if the initial position was 0.2 meters, the cart has traveled 0.05 meters when the position would be 0.2 plus 0.05, or a total of 0.25 meters. Now that we understand that, we can use the multi-coordinate tool to find the velocity of the cart at each of the positions that correspond to the different distances in the data table in the lab. So here's the multi-coordinate tool, for example. And so find the position where it's gone 0.05 meters, and then record that velocity. Then when it's gone 0.1, 0.15, and so on. From that data, you're going to create a graph that will help you develop the relationship between the distance the cart has moved and its kinetic energy. The equation of your graph will yield an important physics theorem that will let you predict how the cart and anything else will move in a given system. The question and analysis section of the lab will help you and test your understanding of the results. Physics is about developing an experimental approach to systematically answer your questions about nature. This sometimes results in uncovering a fundamental relationship. The PASCO wireless sensors make this a lot easier and more efficient. Good luck with your lab.